This is an image of Times Square in New York City. Have you ever stood in the middle of Times Square? There is a lot going on. It can be difficult to know where to look, and it is easy to get overwhelmed. Depending on how familiar you are with the city, Times Square can be an example for many of an overload of extraneous cognitive load. Welcome to Best Practices in Reducing Extraneous Cognitive Load. I am your host, Sarah Finnegan. We will spend the next 10 minutes or so talking about why we have these overwhelming moments, like when standing in the middle of Times Square, and ways we can reduce them for our learners. Unfortunately, we sometimes have Times Square situations in education. It is easy to overload students' working memory with multimedia in the classroom. Perhaps we reason that our students are used to multitasking and all kinds of stimulating input. So we include technology in our instruction to spice it up and make it more exciting. According to Dr. Richard Mayer, Distinguished Professor of Psychology at the University of California, Santa Barbara, and author of the book Multimedia Learning, what students really need for deeper learning is the reduction of extraneous processing, so that they can focus on making mental connections for learning. Here's how he describes the situation.
Just making technology available to people doesn't work very well. We know that from the whole history of educational technology, of all the failed technologies that have been out there. Making it available is not enough. It has to be integrated into the instructional program in a way that makes sense.
In his book, Multimedia Learning, Dr. Richard Mayer goes on to discuss his years of research and dozens of studies in which he empirically established principles to guide the use of multimedia for learning. We will use Mayer's principles to develop a set of best practices for reducing extraneous cognitive load. But let's start by examining cognitive load theory in more detail, including what constitutes cognitive load and how it is defined, including intrinsic, germane, and extraneous cognitive load. Next, we will talk about multimedia principles and how multimedia impacts cognitive load. Finally, we will explore how multimedia principles influence cognitive load and delve into how we can use best practices in learning design to ensure we are avoiding extraneous cognitive load for our learners. Mayer bases his research on cognitive load theory, which suggests that learning takes place when people organize information into a framework that makes sense to them. In this model, information passes into sensory memory, where the nervous system transmits sensory input from the ears or eyes to the brain. Sensory memory only lasts for a few seconds. In order for a person to learn, they must choose to select or pay attention to words and images. This brings them to the working memory, where the user organizes the information and makes connections with prior knowledge in order to integrate the new information into long-term memory. Research by Pavio Baddeley also shows that there are two channels in which people can process information. The right side of the brain is primarily involved in processing images, while the left side of the brain processes verbal information. Therefore, multimedia has the opportunity of maximizing cognitive processing by engaging both channels. But as you can see, there's a lot going on in our brains when learning. Not just input straight to storage, but selecting, sometimes conversion, organizing, and integrating. Multimedia can improve learning, but only if it's used within the limits of working memory. People can hold a few words or images in working memory at a time. Studies show that there are no limits to sensory perception. So much input around us all the time. There is also no limit to long-term memory. However, the gateway into long-term memory is limited. This is evidenced by many studies in which people are asked to remember strings of numbers and repeat them backwards. Generally, the limit is 5 to 7. This can be improved by chunking, but people still can only hold 5 to 7 chunks in working memory at a time. This is why it is important to think about cognitive load and how to reduce it. In order to do that, it is helpful to think about different types of cognitive load. Cognitive load itself is defined using 3 different terms: intrinsic, germane, and extraneous. The first, intrinsic load, is considered the base load of content. It is not influenced by instructional design and is considered relative to the subject matter at hand. Intrinsic load changes as the content changes. Next, germane load is the work of learning. It is the job to be done. Germane load is impacted by instructional design. Finally, extraneous load is the additive load. It is influenced by instructional design and impacts both germane and intrinsic load. As instructional designers, our role is to reduce extraneous cognitive load so learners are able to focus on the important aspects of the subject matter at hand. Now let's switch gears and explore multimedia. What is multimedia? Multimedia is the use of both words and pictures together. Words can be printed or audible or both, and pictures can be static or dynamic. Multimedia messages must be designed in ways that are consistent with how the human brain works. Remember the dual channels in which people can process information? Our goal as instructional designers is to optimize the way in which our dual channels use the information presented in our learning experiences, and not flood learners with extraneous cognitive load, which has been proven to limit the ability to learn. Research has shown that people learn better from words and pictures than from words alone. This means when designing learning, it is best to include objective-aligned images as much as possible. Next, we will talk more about specific ways to reduce extraneous cognitive load using research-based principles developed by Dr. Richard Mayer himself. The next few minutes, we will explore different best practices in how to design learning while keeping cognitive load in mind. These practices are part of Mayer's multimedia principles and have been proven through research. They include the redundancy principle, the spatial contiguity principle, the temporal contiguity principle, and designing segmented versus continuous content or ensuring content is appropriately chunked. The first best practice we will discuss is the elimination of redundancy in learning design. This principle includes explaining visuals with audio or text, but not with both audio and text. Extraneous cognitive load occurs when information is presented in multiple ways to the same channel. Eliminating redundancy as much as possible reduces extraneous cognitive load. Designers should avoid presenting animation, narration, and on-screen text simultaneously. Text and animation together will overload the visual channel. Designers should instead either present animation with narration and no text, or present narration with on-screen visuals concurrently. Why? People read and hear at different speeds, creating a jarring cognitive effect. This is the principle of spatial contiguity, which tells us to present corresponding words and pictures adjacent on the page or screen, or integrated. Remember that text on a screen is processed initially as an image and then converted to verbal information. When there is an image and a separate block of text, the visual processing channel can become overloaded. Again, we're trying to avoid the split attention effect. However, if the text is integrated with the image, the brain processes them together and cognitive load is reduced. What not to do? Place text far away from the corresponding part of the graphic. What to do instead? Place text close to the corresponding part of the graphic. Cognitive overload occurs when learners must simultaneously utilize working memory and engage in selecting, organizing, and integrating. This often happens when verbal information is presented and then a chart is shown that depicts the previous information. If the learner must remember the prior information in order to interpret the chart, cognitive overload can take place. The principle of temporal contiguity says that all the necessary material must be presented together. If there is too much material to present at once, the material must be broken down into small enough pieces so that it can be shown and explained at the same time. Which leads us to the next best practice. This next best practice is about presenting multimedia messages in user-paced segments rather than a continuous unit. Remember at the beginning of this presentation, we said the gateway into long-term memory is limited? We talked about studies in which people were asked to remember strings of numbers and repeat them back, the limit being about 5 to 7. This can be improved by chunking or making sure that content is segmented. What we do not want to do is present information too quickly or pack too much information together. Instead, we want to present content in user-paced segments. We want to ensure we are giving learners time to process information and essentially give their brains a break. Organizing content into nuggets of material supports the brain's ability to do the work that is required of learning, or allows germane cognitive load to take effect. The next best practice we will discuss is the modality principle. The modality principle suggests learners learn more deeply from pictures and spoken words. This means whenever possible, we should use visuals to represent the content we are presenting to learners, and those images should be as self-explanatory as possible. This also suggests that whenever possible, spoken words should be illustrated in some way. One of the easiest ways to reduce cognitive load is by signaling. Signaling provides cues that highlight the organization of essential material, thereby reducing extraneous cognitive load throughout the content. Examples of signaling include bolding, underlining, highlighting, and organizing content into bullets. One thing to note is that signaling should be used sparingly to be most effective. And yet another best practice in designing to reduce extraneous cognitive load includes the coherence principle. Designing with the coherence principle in mind includes excluding extraneous words, sounds, and video. Everything that you include in your content should align to the established learning objectives. Remember, illustration, not decoration. This includes background sound, non-essential images, and any additional treatment that does not somehow align to the learning goals. As a reminder, the following are important practices to consider when designing learning. Avoid redundancy. Present only one thing to each channel. Remember spatial contiguity. Keep explanatory text close to the image. Include temporal contiguity. Present explanation and visualization at the same time. Practice segmenting. Break up complex ideas or visuals into small user-paced pieces. Remember modality. Use narration instead of on-screen text whenever possible. Practice signaling. Create mental cues to highlight what is most important. And focus on coherence. Eliminate anything that is distracting or unnecessary. That concludes our session on cognitive load. Thank you for watching and happy designing!